Lesson 7 is doing the same thing as Lesson 6, where we're solving systems of a quadratic and linear equations, only it is in word problem form. So I'm going to read the first problem. I do have a drawing off to the side. I'll explain that in a moment. A water balloon is launched from a catapult on the ground and follows a parabolic path. So basically, the purple U shape is how the water balloon would start. It would start from the ground, from a catapult, meaning it's going to get kind of slung into the air, and then kind of follow this U-shaped pattern until it falls down to the ground. And at the same time, a dart is fired from a height of 8 feet and follows a straight path. So the dart is going downward, and if you notice, it is potentially going to hit in 2 different places where the balloon possibly could be, as it was going up in the air and then back down. So we're going to set up a system, and we're going to follow the same steps. So I'm going to highlight what we'll be using. Well, we're going to use the 2 equations that are given, and I'm going to set them equal to each other. So negative x squared, I always want to put my squared term first, equals the linear term, the one with just x. I want to set it equal to 0, so I'm going to add x to both sides, and I want to subtract the 8, and if you notice there's no constant term, no single number, so I'm just going to kind of put it at the end. So I have negative x squared, 8x plus 1x is 9x, and then my minus 8 comes down because there was nothing there to combine it with. So at this point we want to do our quadratic formula with our numbers here. So A is unusual, it's going to be negative 1, B is 9, and C is negative 8. The reason that the A is negative is because our parabola shape, our U shape, is going downward. So I'm going to plug it into our formula. X equals opposite sign of B, negative 9, plus or minus the square root. First parenthesis is your B value, squared, minus 4 times the A value, which is negative 1, times the C value, which is negative 8, all over 2 times the A value, which is negative 1. So just as before, when we do quadratic formula, we want to figure out what's underneath the square root. So I'll get the calculator out. So I'm putting everything in the calculator that's under the square root. 9 squared minus 4 times negative 1 times negative 8. And I get the answer of 49. So I'm going to replace all that with 49. So I have x equals negative 9 plus or minus the square root of 49, all over 2 times negative 1 is negative 2. I now want to see if 49 is a perfect square, and it is, just so you know. X equals negative 9 plus or minus the square root of 49. If I put that in my calculator, I should get 7. I will just double check though. Square root of 49 is in fact 7. So I'm replacing the square root with the number 7. Then I have my negative 2 on the bottom. So now at this point I can split this up into 2 separate problems, a plus problem and a minus problem, since I don't have any square roots left. So negative 9 plus 7 divided by negative 2, and negative 9 minus 7 divided by negative 2. This is going to give me my x values. So negative 9 plus 7 is negative 2. Negative 2 divided by negative 2 is 1. I will show you that one in the calculator just so you can see that if you don't know how to do the math in your head, that's okay. You can use this A over B button and just type it in exactly how you see it. Just don't forget about the negative 2 on the bottom. So it does equal 1. And then negative 9 minus 7, that equals negative 16. Negative 16 divided by negative 2 is positive 8. So I've found my 2 x values, and remember that the next step is to plug them in to your linear term to find out what your y value is going to be. So y equals negative x, so negative 1 plus 8. And then y equals negative x, negative 8 plus 8. So if I do the math here, negative 1 plus 8 is 7. So that is one of my y values. And then negative 8 plus 8 is 0. So that's my second y value. So our final answer, where could these potential lines and quadratic U-shape cross? It would be at the 1 and the 7. So 1, 7, and then 8, 0. This 8 and this 0. So we're going to try a few more problems. Again, same stuff from the last lesson, just in word problem form. Okay, another water balloon / dart problem. So again, the water balloon is thrown from the ground and follows a U shape, and then the dart is thrown from a taller height going downwards. And that's why you have those negatives there. So I'm going to highlight the two equations that I'm going to be setting equal to each other. And I'm going to start by writing negative x squared plus 6x equals negative x plus 6. So I want to do a wall and floor. I want to add x. Make sure I put it under the x value. There's no constant number, so minus 6 is just going to have to be stuck at the end there. So negative x squared gets brought down. 6x plus 1x is 7x. And the negative 6 is just kind of alone, and we just bring it down. Now I can do the quadratic formula. So a equals negative 1, b equals 7, c equals negative 6. So x equals opposite sign of b, negative 7, plus or minus the square root. 7 squared, the b value, minus 4 times 1, which is negative 1, times c, which is negative 6, all over 2 times negative 1. I'm going to put underneath the square root into the calculator now. And I get the answer of 25. So I'm going to rewrite that. So I have x equals negative 7 plus or minus square root 25, and then 2 times negative 1 is negative 2. The square root of 25 is a perfect square. Its square root of 25 is 5. So I'm going to replace the 25 with just a 5, no square root anymore. And now I can split this up. So I'm going to write negative 7 plus 5 divided by negative 2, and negative 7 minus 5 divided by negative 2 to get two answers. Negative 7 plus 5 is negative 2. Negative 2 divided by negative 2 is positive 1. That's one x value. Negative 7 minus 5 is negative 12. Negative 12 divided by negative 2 is positive 6. So there's my second x value. I'm then going to take those two answers and plug them into my linear term to find the y value. So y equals negative x, which is 1, plus 6, and then y equals the new negative, the x value is 6 plus 6. So first equation, negative 1 plus 6 is 5, and negative 6 plus 6 is 0. So my final answer, first pair are these two numbers, 1 and 5. That's the first ordered pair. Second are these two numbers, 6 and 0. So we'll move on to a couple more examples. All right, the next one. A pelican flying in the air over water drops a crab from a height of 30 feet. The distance between the falling crab and the water can be represented by the function of y equals negative 16 t squared plus 30, where t is time in seconds. To catch the crab as it falls, a seagull flies along a path represented by this function. Can the seagull catch the crab before the crab hits the water? So we're going to basically do exactly what we've been doing. We're going to take our two equations and set them equal to each other. And I'm going to just make it x to make it a little easier. So I just changed the t into an x. They put t to make it so that you understood that it was talking about time. Next step, I'm going to set it equal to 0. So I have to add 8x. I don't see a x value, so I kind of have to put it in the middle there. And then I'm going to subtract 15, put it underneath that 30. So I have negative 16x squared plus 8x, because that was alone. And then 30 minus 15 is 15. The right side cancels. Now I can do my quadratic formula. So a is going to be a different number. I have negative 16, b is 8, c is 15. So we're going to have some big numbers on this. So x equals opposite sign of b, negative 8 plus or minus the square root. 8 squared minus 4 times a times c all over 2 times a. Now I take what's under the radical and I put it in the calculator to see what that equals. Make sure you do your signs correctly every time. So I'm just copying exactly what I wrote down. And I get 1024, 1024. So I'm going to rewrite that. So I have x equals negative 8 plus or minus the square root of 1024 all over 2 times negative 16 is negative 32. All right, so now I need to see if the square root of 1024 is a perfect square. And it is, it equals 32. So I'm going to write x equals negative 8 plus or minus 32 divided by negative 32. And now I can split this up into two separate problems. Negative 8 plus 32 divided by negative 32, and negative 8 minus 32 divided by negative 32. So I'm going to put those in the calculator because they're kind of big numbers. And I'm going to use that a over b button. So I got negative 8 plus 32 divided by negative 32. And I get negative 0.75. I'm going to hit enter, and I'm going to put the next fraction in. Negative 8 minus 32 over negative 32. And I get 1.25. So I'm going to write those two numbers down, negative 0.75 and 1.25. All right, last step would be to plug in your values into that linear equation. So I have y equals negative 8 times negative 0.75 plus 15, and then y equals negative 8 times 1.25 plus 15. We're definitely going to need a calculator for this. So negative 8 times negative 0.75. Make sure I have that right. Plus 15. Equals 21. All right, so 21 is my y value. And then the next one, put that in the calculator. I'm just going to change this number to 1.25. And I get 5. Okay, so our final places where these two things would connect would be, these two are your ordered pairs. So we have negative 0.75 comma 21 and then 1.25 comma 5. Now The question was asking, can the seagull catch the crab before the crab hits the water? Remember that in the problem it said that the t value, which I changed to x, meant time. So in the end, can the seagull catch the crab before it hits the water? Yes, but the only answer that would make sense would be this answer, because if you think about negative 0.75, that's talking about time, and there's no such thing as negative time. So this would be your final answer. Kind of a weird question.